Okay, what I've done here is made a little chart so that we can kind of organize our thoughts about parallelograms. So notice I titled the chart quadrilaterals because we're going to talk about quadrilaterals today. And all quadrilaterals have four sides and all of their interior angles are 360 degrees. This is not special of parallelograms, and this is not special of parallelograms. This is true of any quadrilateral. Even a quadrilateral that looks like this, which is not a square or a parallelogram or a rhombus or anything else like that. Even that has four sides, and even those four angles would add up to 360 degrees. So these are just things that are true of all quadrilaterals. Okay. Then we have special kinds of quadrilaterals, and there's even more than these four. There's also trapezoids and trapeziums, which we haven't even talked about yet. We have special kinds of quadrilaterals, and we've talked about the parallelogram for the most part. And we have all agreed that in a parallelogram, the opposite sides are parallel. Yes? Yes. So I'm just going to put a little check mark or an X in there that says, yes, in a parallelogram, the opposite sides are parallel. Are the opposite sides congruent in a parallelogram? Yes, they are. Are the opposite angles congruent in a parallelogram? Yes, they are. Are the consecutive angles supplementary? The angles right next to each other, do they equal 180?
Yes.
Yes, they do. Do the diagonals bisect each other? Yes, they do. Now, I've taken the notes from, and since the screen is recording, I'm going to go ahead and go here. It's recording everything I do on my computer. I've taken my notes from class yesterday and the day before that, and I have my parallelogram notes right here, so they're available to you all. Okay? At all? Okay, so this is what I did. This is what we've learned about parallelograms so far, but I changed the color of some of the bullets because parallelograms, everything in green is true of a parallelogram. It's a quadrilateral with two pairs of parallel sides. Its opposite sides are congruent. Its opposite angles are congruent. The diagonals do form two pairs of congruent triangles. The diagonals bisect each other, and the consecutive angles are supplementary. The angles adding up to 360 is not true of just parallelograms, so that's in black now. And the diagonals are not congruent is true in a parallelogram, but it is not true in all quadrilaterals. So I think I want to add that right here. I left you room to add some things. So let's add that. Get back here to my thing. Let's add that the diagonals are not congruent. Help if I could spell it right. The diagonals are not congruent is true of a parallelogram. Okay? Like I said, this gets a little bit confusing. So what I'm going to do is I'm going to star these few things. These things that I already printed, I'm going to star. And then over here, I'm going to make myself a note. That this is true. This is, how do I want to say this? Properties of all parallelograms. These are properties of all parallelograms. Everything with a star. And anything we add to this list is just going to be specific properties of certain parallelograms. I don't know if you'll be able to see this
I can't read that.
on the
What
screen.
does it say? Properties of.
Of all parallelograms. Okay, I think you can see it. Okay, is everybody caught up now? I have to be behind my table, sorry. So what I've done now is I've taken some little, I forgot what these are even called. These are little plastic things that join. I don't even know what they're called. They're called geo-connectors. And they come in all different sizes and everything. And I've just made a parallelogram. You can see it on the screen right there. See it? Okay. And how did I make it? Well, I made sure the top and bottom were made out of the same size piece. And I made sure the sides were made out of the same size piece. And because of the way they're connected, you can see, I know you can't see them all, but if you just look at the red stripes, no matter what I do, look at the parallelism of the red. Do they always stay the same distance apart? The top and bottom lines, do they always stay the same distance apart? I mean, they're always, I'm going to show it to you now. Here, it's easier for you guys to sit this way. I'm trying to check if these are always parallel to each other.
Yeah, they are.
No matter what I do.
Oh, yeah, they're always parallel, but they're not the same distance.
Well, I mean, the same distance from here to here. This distance is the same as this distance.
Oh, yeah. I thought
Okay,
you meant
that's
like
what-
changing.
Yeah, okay. So they always stay parallel to each other. And the green lines,
Yeah.
they're always staying parallel to each other, right? No matter what I do. Now think about, in a parallelogram, think about this angle right here and this angle right here. And look at the size of them, and are they always staying the same size? Because I'm going to make this one smaller. So if I make this one smaller, this one should get smaller, right? So, yes? Yes, I'm making it both of them smaller by the same amount every time. Likewise, these are both obtuse right now, but as I move this, they both get smaller at the same rate, right? So they're staying the same measure each time as well, right? Yep. But they're staying the same measure no matter what I do, right? Now I want you to think about the diagonal in here that goes from here to here, and the diagonal from here to here. Is this diagonal the same as this diagonal? We talked about this the other day. This one's going to be shorter, isn't it? This one's going to be shorter. Unless I do that, and then the diagonals become the same, right? But if I do this, okay. So that's why in this check mark, we have for parallelograms, the diagonals are not congruent, okay, for all parallelograms. But once I do this to my parallelogram, I still have a parallelogram, mind you, because every one of these bullets is still satisfied. The opposite sides are parallel, the opposite sides are congruent, the opposite angles are congruent, the consecutive angles are supplementary, and the diagonals do bisect each other. But all of a sudden I have a special parallelogram, which we all learned in the first grade was called a what?
Square.
That's not a square. What is it? It's a rectangle. So, a rectangle has all of these qualities. Not that the diagonals are congruent, or the diagonals are not congruent, however. It makes it a parallelogram because it has all of these 5 things. But it's a special parallelogram. Tell me one way that I know this is a rectangle and not a parallelogram.
All the angles are the same.
All the angles are the same, and not only that, but all the angles measure what? Okay, so I'm going to write that down here. It has 4 right angles. And I'm going to put a check right there, because in a rectangle, I have 4 right angles. But this is not checked, if you'll notice, because the diagonals are not congruent, it says. And in a rectangle, this line, this diagonal, would be exactly the same size as this diagonal. So the diagonals would definitely be congruent to each other. Okay? They're still going to bisect each other. The diagonals are still going to cut each other in half. But now they're going to be congruent. So I'll leave that up to you. If you want to add the diagonals are congruent and check it, that's great. But since there's not a check mark here, we already know that the diagonals are not congruent. All right? So that's something totally up to you that you can add. So, in a rectangle, we have an extra special quality. We know a rectangle is a parallelogram, but it has a special quality in that it has 4 right angles. And that the diagonals are congruent. I think I better add that. Let's put that on there. The diagonals are congruent. Let's do it. The diagonals are congruent. I think that's important. Now, I'm not a very good drawer here, but I want you to think about if this is a rectangle and the diagonals are congruent, and I already know that they bisect each other because I've already checked that, this piece is the same as this piece, and we know this piece is the same as this piece, but because the long diagonal is equal to each other, these also get the same amount of markings. These all 4 are the same size. All 4 of these lines. We're in a regular parallelogram. Remember when we marked those, we marked this piece was congruent to this piece, but this piece and this piece are congruent to each other, but all 4 of them are not the same. Does that make sense? Yes? Okay. Now, so what I need you to know from here is that a rectangle is a parallelogram. It's a special kind of parallelogram that has 4 right angles and the diagonals are congruent to each other. These are the 2 extra things that make a rectangle a special parallelogram. Okay? If I go back to my regular parallelogram, actually, I'm going to go ahead back to my rectangle. Let me think about that. I think I'll go back to my regular parallelogram. And I changed it just a little bit. It's still going to be a parallelogram. I got one in here. Lucky me. This is still a parallelogram because top and bottom are parallel. Left and right are parallel. Right? Angles opposite are congruent. Angles opposite are congruent. Everybody got that? Still a parallelogram. Okay. But now my sides, this side is congruent to this side, and this side is congruent to this side. This is great. Okay? But what's the one thing I changed about it? All the sides are the same, right? So once again, for Micah's sake, we're going to touch on all of these as looking at our qualities here. My opposite sides are still parallel to each other. My opposite sides are congruent. This is congruent to this, and this is congruent to this. My opposite angles are congruent. Still the same. These are still supplementary. These still equal 180, and these 2 would equal 180, etc. And my diagonals still bisect each other. But I've added an extra quality to it and said that all 4 sides are equal. So that's the next quality I'm going to add here, is that all four sides are congruent. When I do that to a parallelogram, I now have a rhombus. This is a special parallelogram called a rhombus. So I know a rhombus has all four sides that are congruent. It has these 5 main qualities. Okay. How about this? What about the diagonals? Are the diagonals congruent or not congruent?
No.
I mean, and I can do it like this and you can actually see better. This diagonal is going to be a lot longer than this one, isn't it? So the diagonals are not congruent in a rhombus. Does a rhombus have 4 right angles?
No.
No, rhombus doesn't have 4 right angles. Do the diagonal, or the diagonals are congruent, we're not going to mark that, but all 4 sides are the same. Okay? So, a rhombus is a parallelogram because all of these 5 qualities are matched here. A rhombus is a parallelogram with this special property. Okay? Now, there are extra special things that happen in